At 7 in the morning on Monday the 6th of July, on a 33 square mile island in the western Pacific called Rota, the wind stopped. Not because the storm had passed, because the eye of Super Typhoon Bavi was directly overhead. 180 miles per hour winds, a central pressure of 910 millibars, and as far as anyone can tell, the first Category 5 in the recorded history of that island whose eye passed straight over the top of it. And the wind speed is not the story. 82 days earlier, another super typhoon had already collapsed the electrical grid on the islands just to the north. When Bavi arrived, thousands of Americans were still living without power from the first one. The shelters were full. They were turning people away. Here is what actually decides whether a storm like this kills people, and why the Marianas typhoon season has not even started yet. Start with why this keeps happening here, because the geography is not an accident. The western Pacific Ocean north of the equator is the most active tropical cyclone basin on the planet. In an average year, 25 or 26 named storms form in that stretch of open water, and 16 of them become typhoons. That is roughly a dozen more storms than the entire Atlantic hurricane season produces, and 9 more hurricanes. The Mariana Islands sit almost exactly in the middle of that firing range. On average, Guam and the Northern Marianas are affected by a tropical storm or a typhoon 6 or 7 times every single year. The reason is the water. Sea surface temperatures around the Marianas in early July were sitting near 30 degrees Celsius, about 86 degrees Fahrenheit, and the warmth extends well below the surface. That matters more than most people realize. A hurricane churns the ocean underneath itself like a mixer, and if the warm layer is thin, the storm dredges up cold water and chokes on its own fuel supply. If the warm layer is deep, it does not. The storm just keeps drinking, which is why Bavi did what it did. It became a tropical storm on the 1st of July. 2 days later, it was a typhoon. Hours after that, it was a super typhoon. From a disorganized cluster of thunderstorms to a Category 5 in roughly 3 days. And here is the detail I have not been able to stop thinking about since I read it. On the day Bavi hit Rota, meteorologists at the University of Wisconsin calculated the maximum potential intensity of that patch of ocean, the theoretical ceiling, the strongest storm the water and the atmosphere could physically support. That ceiling was somewhere around 200 miles per hour. Bavi came in at 180 miles per hour. Storms almost never reach their ceiling. Everything has to be perfect, and the atmosphere is a messy, complicated system where perfect almost never happens. Bavi got within about 20 miles per hour of the absolute physical maximum the ocean had to give that morning. The ocean was not out of fuel. Bavi simply ran out of time before it hit land. Now hold that thought, because there is a second piece of geography that makes these islands uniquely exposed, and it is the reason a storm like this behaves so differently here than it would on the mainland. When a hurricane makes landfall on a continent, it starts DYing immediately. It loses contact with the warm water that feeds it. Friction from the land tears at the circulation, and within hours, it is falling apart. That is why a Category 5 hitting Florida is a Category 2 by the time it reaches Georgia. Rota is 33 square miles. A storm does not cross 33 square miles. It steps over it. Bavi did not weaken over Rota. It could not. There was not enough island underneath it to do any damage to it at all. The full Category 5 eye wall came ashore at full strength, and because the eye passed directly overhead rather than clipping the coast, the island got the eye wall twice. Once from one direction, then 20 or 30 minutes of eerie, sunlit calm as the eye passed over, and then the eye wall again from the exact opposite direction. That reversal is what destroys buildings. A roof that held through the first half has been loosened, its fasteners worked and worried for an hour, and then the wind comes back and pulls on it from the other side. Anything that survived round 1 is now being tested in the direction it was never designed for. The mayor of Rota, Aubrey Hokog, described the island afterward in a phone call to Stars and Stripes. She said it had been damaged in, and I am quoting her, every aspect: public facilities, government assets, private homes, the airport, the seaport, 2,000 people, no power, no running water. They tapped a reservoir to keep water flowing at all. And now here is the fact that reframes the whole story, and it has nothing to do with Bavi. 82 days before that eye wall crossed Rota, another super typhoon had already been here. Super Typhoon Sinlaku made landfall over Tinian and Saipan on the 14th and 15th of April. At the time, it was the strongest tropical cyclone anywhere on Earth in 2026, and the strongest storm to form in the Northern Hemisphere in the month of April since 2021. In the 24 hours before it arrived, it rapidly intensified by 75 miles per hour. Residents in the Marianas have a name for the kind of weak, sloppy storm Sinlaku looked like a few days out. They call it a banana typhoon because it knocks over the banana trees and leaves everything else standing. It did not stay a banana typhoon. Now, I want to correct something before we go any further, because you are going to see this event described as 2 Category 5s in 90 days, and that is not quite right. Bavi was a Category 5. Sinlaku, at the moment it came ashore over northern Tinian, was closer to a strong Category 4, with sustained winds around 145 to 150 miles per hour. Both were super typhoons, which is a separate designation the Joint Typhoon Warning Center uses for anything above 150. But if you want the technically accurate version, it was 1 Category 5 and 1 very strong Category 4. I am telling you that because the correction does not help. It makes the story worse, because Sinlaku's weapon was never its peak wind speed, it was its speed over the ground. Sinlaku had almost no steering currents pushing it along, and it crawled. It sat over the southern northern Marianas for hours, dragging its eye wall across the same villages over and over, dumping more than 20 inches of rain. 2 days after landfall, it was still only about 170 miles away, drifting north at 3 miles per hour. The entire electrical grid on Saipan and Tinian collapsed. Not damaged. Collapsed. The communication towers went down with it, so people lost mobile service and internet at the same moment they lost the lights. In the residential districts, the wind was strong enough to flip cars and stack them on top of one another. Wooden homes and tin-roofed homes were simply demolished. And even the concrete houses, the ones that held, took on water through every crevice in the structure. One of the people in one of those houses was a woman named Catlin de los Reyes. She is Chamorro, indigenous to the Mariana Islands, and she has lived on Saipan her whole life. She had been through Typhoon Saudalor in 2015. She had been through Super Typhoon U2 in 2018, a Category 5 with 175 miles per hour winds that ripped through her village in the southern end of the island. She knew exactly what a typhoon was. She told a reporter from Grist that Sinlaku was different. Her words were, "At the beginning, it was okay, but later on, it wasn't. Remember her. We are going to come back to her, and she is the reason this story matters." So, April 14th, the grid collapses. July 6th, the eye of a Category 5 passes over Rota, 82 days. And the question that decides the entire outcome of this story is a question almost nobody in the coverage asked. What actually got rebuilt in those 82 days? Here is the answer, and I want to lay it out slowly because this is the part that will stay with you. 2 weeks after Sinlaku, more than 15,000 people on Saipan still had no electricity. Water service across the island was running at about 33%. On Tinian, the island's power plant had been critically damaged, and the entire island, every home, every business, every street, was still dark. Now, Tinian is small. Before the storm, the peak electrical demand for the entire island was slightly below 3 megawatts. 3 megawatts. That is not a city. That is a large shopping mall on the mainland. That is a rounding error on any grid in the continental United States. And it took until the 28th of May for the Army Corps of Engineers and the Army's 249th Engineer Battalion to get large-scale generators feeding power back into Tinian's grid. That is 44 days after landfall. 44 days to restore 3 megawatts. That is not a story about anybody failing. The Corps of Engineers was pre-positioned on Guam before the storm even arrived. FEMA was on the ground. The Navy sent a ship. Marines were clearing fallen trees at Ipao Beach within a week. Seabees were putting up FEMA-approved tents for families whose homes were gone. Everybody moved fast. The problem is that in the Marianas, fast is still slow. Every replacement pole, every transformer, every roll of wire, every generator has to come across the Pacific Ocean by ship into ports that the storm also damaged. Every roof has to be built out of materials that were not on the island a month ago. There is no neighboring state to borrow crews from. There is no grid next door to import power from. There is only the ocean and a supply chain thousands of miles long. And so, more than a month after Sinlaku, this is what the Northern Marianas actually looked like. Debris still piled along the roadsides in Garapan, the center of Saipan's tourist district. Families sleeping with the windows open in 80-degree heat and full tropical humidity because there was no power for a fan. Indigenous fishermen going out to catch tiao, a small goatfish, because with no electricity there was no refrigeration, so dinner had to be caught fresh that day. Children out of school because the schoolhouses themselves had been destroyed, and many of them were not expected to reopen for months. And here is the one that gets me. On Guam, which had been spared the worst of Sinlaku, people bought so many battery-powered Ryobi fans to ship to their relatives on Saipan and Tinian that the Home Depot ran out. Sit with that for a second, because it is the whole story in one image. An entire island community, 80 miles away, buying every battery fan on the shelf and putting them on a plane for their families, because the lights were not coming back. That was the state of the Northern Mariana Islands when a Category 5 super typhoon appeared on the satellite. More than 15,000 Americans had spent 2.5 months in the dark. Roofs were still blue tarps. 450 families were living under emergency tents and temporary roofing, and the shelters, which are mostly schools, were being asked to absorb another wave of people from homes that had already been destroyed once. Landon Aidlet is a meteorologist with the National Weather Service in Guam. Speaking to NPR while Bavi was still inbound, he said this: "From what I've heard from Saipan and Tinian, where many people still have no power, 2.5 months after Sinlaku ravaged those islands, the shelters are packed and they had to turn people away. So understand what actually happened on the 6th of July. Bavi did not hit an island. Bavi hit a recovery. It hit a construction site halfway through the rebuild, with the walls open and the roofs off, and the grid held together by borrowed generators. And this is the number I want you to take out of this video, not 180, 82. Because the thing that determines whether a natural disaster becomes a mass casualty event is almost never the peak wind speed. It is the interval. It is how many days a community got to put itself back together before the next one arrived. Every system that keeps people alive during a storm, the shelters, the hospitals, the grid, the water pumps, the roads, the neighbors with a concrete house and a spare room, all of it has a recovery time. And if the storms start arriving faster than that recovery time, the second storm does not add to the first one, it multiplies it. Which brings us to the part of this that is genuinely hard to talk about, which is how a typhoon actually kills you. It is almost never the wind. On Rota, where the eye of a 180 miles per hour Category 5 passed directly overhead, the death toll was 0. 2 people were injured. That is it. 2,000 people took the strongest storm ever recorded over their island, and every single one of them walked out of it. And that number is not the one to trust, because the storm is not finished with you when the wind stops. Look at what Sinlaku actually did. The regional death toll from that storm, across Guam, the Northern Marianas, and the Federated States of Micronesia, climbed to 17. That made it the deadliest storm in the Micronesian region since 2002. Now look at how those people died. A couple on Guam died of carbon monoxide poisoning. They were running a generator indoors because the power was out, because they wanted to keep the lights on, and the food cold, and the air moving. 6 crew members died aboard a cargo ship called the Mariana when its engine failed and it was caught in the storm. And in Chuuk State, in the Federated States of Micronesia, 9 people died, including a baby, because the baby's pregnant mother could not reach the hospital. The trees had come down across the road. That is what the aftermath does. Not one of those deaths was caused by wind hitting a person. They were caused by a generator in a closed room, by an engine failing at the wrong moment, by a road that no ambulance could drive down, and every single one of those failures gets worse the longer the recovery takes. In the tropics, with no electricity, the temperature inside a house sits in the 80s with humidity that never breaks. There is no refrigeration, which means insulin spoils. There is no power, which means an oxygen concentrator does not run, and a dialysis clinic does not open. The water pumps need electricity, which is why Saipan's water service was at 1/3 2 weeks in, and the roads stay blocked, which means the ambulance does not come. Catlin Delos Reyes, the woman from Saipan, understood this immediately. The very first thing she and her family did after Sinlaku, before the roof, before anything, was clear the debris out of their driveway, not to get their car out, so that an ambulance could get in. She is the primary caregiver for her 94-year-old mother who has dementia and has been bedridden for 7 years. That is the mechanism. That is how a storm kills people 3 weeks after it has left the island and stopped being on the news. And we know this works exactly the way I am describing, because it has already been demonstrated twice in American territory, and the 2 results could not be further apart. In October of 2018, Super Typhoon U2 made a direct landfall on Saipan and Tinian as a Category 5, with sustained winds of 175 miles per hour. It remains one of the strongest storms ever to strike United States soil. It tore apart the Saipan airport, stripped the vegetation off entire hillsides, and damaged or destroyed thousands of buildings. 2 people died. 1 year earlier, Hurricane Maria made landfall in Puerto Rico as a strong Category 4, with winds weaker than U2's. The official death toll from Maria was set at 64. Independent academic studies later put the real number in the thousands, with the most widely cited estimate landing near 3,000, and almost none of those people were killed by the wind either. They died in the months afterward, in a territory where the electrical grid stayed down for the better part of a year, where hospitals ran on generators and then ran out of fuel, where people on dialysis missed sessions, and people on oxygen went without, and the emergency rooms could not be reached. Same country, same ocean, same category of storm. 2 dead in one place, thousands in the other. The variable was never the wind. The variable was what was standing when the storm arrived, and how fast it came back afterward. And I want to give the Marianas their due here, because they earned it the hard way. These islands are extremely good at this. The building codes are serious. The concrete houses hold. People drill for this. When a storm comes, the family with the reinforced concrete home opens the doors, and the whole block goes inside. And that is not a policy. It is just what people do. Warnings go out days in advance, and people listen. The National Weather Service told Rota residents to treat the incoming eye wall like an approaching tornado and get to an interior room immediately, and they did. 2,000 people in the path of a Category 5, and 0 of them died. That competence is real, and it is the only reason we are not talking about a body count right now. But here's the thing about that competence. It was built for a Category 5 every few years. It has never once been tested against a Category 5, arriving while the island is still rebuilding from the last one. YouTube proved the Marianas can survive one super typhoon. Nobody has ever tested whether they can survive two. If you want to keep following stories like this one, the ones that stay after the cameras leave, subscribe. That is the only thing I will ask for. Now, there is a question that shows up under every single story about these islands, and it is usually the top comment, and I want to answer it properly instead of pretending it is not there. The question is, why do people even live there? The first answer is history. Chamorro people have been in the Mariana Islands for something on the order of 3,500 years. The Refaluwash, or Carolinian, community has been there for generations. This is not a place people wandered into. It is a homeland that predates almost every other political entity in this story by millennia. The second answer is that these are Americans. The people on Guam and in the northern Mariana Islands are United States citizens. About 200,000 of them. They pay into the same federal system and they answer the same Federal Emergency Management Agency, and when the storm hits, the Army Corps of Engineers and the Navy and the Marines show up because it is domestic soil. Guam is also home to Andersen Air Force Base and a major naval installation, which makes it one of the most strategically important pieces of ground the United States holds anywhere on Earth. The United States does not merely permit people to live in the Marianas, it very much needs them to. And the third answer is the one Catlin de los Reyes gave, without ever being asked the question. Her mother is 94, she has dementia, she has been bedridden for 7 years, and her daughter is the one who takes care of her. That is why she stays, no matter how many times the roof comes off, no matter how many times she has to drag a soaked mattress out into the sun to dry. If you have ever wondered why people do not just leave, that is the answer, and it is the same answer everywhere. People do not live on a map, they live next to their mother. Now let me be careful about the climate question, because this is exactly the point where a lot of coverage overreaches, and I would rather you heard the honest version from me. You will see people say that climate change means more typhoons. That is not what the science actually says, and if you repeat it, you will get corrected correctly. The global count of tropical cyclones is not clearly increasing. Some research suggests the total number may even edge slightly downward. What the research does support is narrower and, unfortunately, more relevant to this story. The proportion of storms that reach the top of the intensity scale appears to be increasing. And rapid intensification, the thing where a storm gains enormous strength in under 24 hours, is happening more often because the fuel is warmer and it goes deeper. Look at what these two storms actually did. Sinlaku gained 75 miles per hour of wind speed in a single day. Bavi went from a tropical storm to within roughly 20 miles per hour of the physical ceiling of what the ocean could produce in about 3 days. That is not more storms. That is the same number of storms, arriving with less warning and hitting harder at the top end. Anyone who tells you the number of typhoons is going up is ahead of the data. And I want to be clear that this correction does not make anything better. It makes it more specific, because a system built to recover from a Category 3 does not fail gracefully when a Category 5 shows up instead. Which brings us to the calendar, and the calendar is the worst part. The Marianas typhoon season runs from June through December. Sinlaku hit in April. That was before the season. Bavi hit on the 6th of July. That is the first week of it. 2 super typhoons, one of them a Category 5 that passed its eye directly over an American island, and we are not even out of the opening act. Look at when the Marianas historically get hit hardest. Super Typhoon Yutu, the Category 5 that flattened Saipan and Tinian, was late October. Typhoon Saudalor was August. Typhoon Pongsona, which devastated Guam, was December. The marquee disasters in these islands cluster in the back half of the year, and the back half of the year has not started. On average, 6 or 7 tropical storms or typhoons affect these islands every year. 2 have arrived. There are 5 months left. And right now, as I am recording this, there are still people on Saipan and Tinian whose lateral power lines have not been reconnected since April. The utility's own language for those neighborhoods, in a press conference after Bavi, was that they remain a work in progress. Rota has 2,000 people and no grid. The airport and seaport are damaged, and the 82-day clock that started in April has now been reset from a lower baseline, with the ocean still at 86 degrees. So here is what I would actually do with all of this. If you live anywhere a storm can reach, and that is most of you, the things that kill people in the aftermath are boring and preventable, and they are worth 10 minutes of your attention right now. Never run a generator indoors, in a garage, or anywhere near a window, because carbon monoxide has no smell, and it killed a couple on Guam 3 months ago. Know how you would keep insulin or any refrigerated medication cold for a week without power. Store water, because the pumps run on electricity, and when the grid dies, the taps die with it, about a day later. Keep your driveway clear enough for an ambulance, not just your car. And know which of your neighbors cannot walk out on their own, because in every one of these events, those are the people who die, and they die quietly, at home, in the weeks after the storm stops being news. And if you are watching this from the mainland, understand what you are actually looking at. This is a domestic American disaster. The recovery is a line item that somebody in Washington votes on. The speed of that line item is, quite literally, the interval. It is the 82 days. It is the thing that decides what is standing when the next one comes. The wind speeds will lead every headline, 180 miles per hour. Category 5. The strongest storm ever recorded over that island. The restoration number will lead none of them. It will sit in a utility press release nobody reads, and it will be the only number that actually tells you what the next typhoon is going to cost. So watch that one instead. Watch how many households on Saipan and Tinian and Rota have power a month from now. Watch whether the schools reopen before the peak of the season or after it, because the storms are coming either way. The ocean is warm and it is July, and the Marianas are exactly where they have always been. The only thing left that anyone can still change is how much is standing when they get here.